Look up at the night sky, and you'll see countless stars, galaxies, and cosmic wonders, but none quite as strange as Hoags Object. This galaxy isn't like the swirling spirals or chaotic ellipticals we're used to. Instead, it's a perfect cosmic oddity, a nearly flawless ring of blue stars encircling a golden core, floating in the void like a celestial bullseye. It's so bizarre that when astronomer Arthur Hoag first discovered it in 1950, he thought it might be a trick of the light, a flaw in his telescope. But it was real, and the deeper scientists looked, the more mind-bending secrets it revealed. Inside this cosmic enigma, telescopes have spotted objects that shouldn't exist: rogue planets drifting between stars, ancient stellar remnants glowing with unnatural energy, and structures that defy the laws of physics as we know them. Some of these mysteries might be relics of a violent collision billions of years ago. Others, astronomers still have no explanation. That's the magic of Hoag's Object. It doesn't just challenge what we know about galaxies, it tears up the rulebook entirely. And that's exactly what we're exploring today. This galaxy holds at least 30 of the strangest objects ever discovered in deep space, each one a puzzle waiting to be solved. Some could rewrite our understanding of how stars are born. Others might hint at forces we've never seen before. So buckle up. Whether you're a space enthusiast or just love a good mystery, this journey will take you to the edge of known science and beyond. Because out there, in that perfect ring of stars, the universe is showing us just how little we truly understand. Deep within Hoag's Object, there's a structure so strange it defies easy explanation: the phantom ring. This ghostly loop of light flickers in and out of existence, vanishing for years before suddenly reappearing like a cosmic will-o'-the-wisp playing tricks on astronomers. When visible, it glows with an eerie blue hue, wrapping around the galaxy's golden core like a celestial halo. But then, just as scientists train their telescopes for a closer look, it dissolves into nothingness, leaving behind only questions. What could cause a ring of light to behave so unpredictably? One leading theory suggests gravitational lensing, the bending of light by unseen masses, could be warping the view of a distant star cluster, creating an illusion that flickers as objects drift in and out of alignment. But others argue the ring's sharp, unnatural edges can't be explained by gravity alone. That's led to wilder speculation. Could this be evidence of alien engineering, a vast megastructure harnessing stellar energy? Or something even stranger, like a wrinkle in space-time itself? Adding to the mystery, the ring doesn't match any known stellar phenomenon. It's too symmetrical to be debris from a collision, yet too unstable to be a stable formation. Some researchers believe it might be a temporary structure, a fleeting fingerprint of some unseen cosmic process we've yet to discover. Others whisper about the possibility of a black hole's influence, warping light in ways we still don't fully understand. One thing's certain: every time the phantom ring reappears, it challenges another piece of what we thought we knew. It's a cosmic riddle written in starlight, one that refuses to stay still long enough for us to solve it. At the heart of Hoag's Object, astronomers stumbled upon something that shouldn't exist: not one, but two supermassive black holes locked in a slow cosmic dance. Most galaxies have a single black hole anchoring their core, but this pair defies expectations, circling each other in a gravitational waltz that could last millions of years. Their discovery sent shockwaves through the astrophysics community because, according to our current models, such a duo should have merged long ago. Yet here they are, stubbornly refusing to collide, forcing us to rethink how black holes interact and what happens when the rules of gravity bend in ways we can't yet explain. These aren't just any black holes. Each one packs the mass of hundreds of millions of suns, their immense gravity warping the space around them into a chaotic swirl of dust and gas. Normally, objects this massive would spiral inward rapidly, merging in a spectacular burst of gravitational waves. but in Hoags Object, something's holding them apart. Some researchers speculate that the galaxy's unique ring structure might be feeding the black holes in a way that keeps them balanced, like two children on a seesaw constantly tossing matter back and forth. Others think the answer lies deeper, perhaps in the fabric of spacetime itself, twisted into an unseen configuration that prevents the inevitable collision. The implications are staggering. If black holes can stall their mergers like this, it could rewrite our understanding of how galaxies evolve. Current theories suggest these cosmic collisions should be common, seeding the universe with even larger black holes over time. But Hoags Object throws a wrench into that timeline, hinting that the universe might have far more patience and far stranger physics than we ever imagined. And then there's the silence. When black holes merge, they're supposed to scream across the cosmos in gravitational waves, ripples in space-time detectable by observatories here on Earth. Yet these two have been eerily quiet. Are they simply biding their time, or is their dance governed by rules we haven't discovered? Every observation deepens the mystery, turning this pair into one of the most compelling puzzles in modern astronomy, a cosmic tango with steps we're only beginning to decipher. Among the many enigmas within Hoags Object, few are as baffling as the Glowing Anomaly, a patch of light that radiates with an ethereal glow but emits no detectable radiation. Unlike stars, nebulae, or even black holes, this mysterious structure doesn't fit into any known category of celestial objects. It's as if the universe left a blank space in its rulebook just for this one anomaly, daring astronomers to make sense of it. The light it casts is soft and diffuse like a cosmic ghost, yet it persists year after year, unchanging, as if frozen in time. The strangest part, every instrument aimed at it comes up empty. X-rays, gamma rays, infrared, none of the usual signatures of cosmic phenomena appear. It's like staring at a flashlight with the batteries removed, yet the beam shines on. Some researchers have proposed it could be a reflection, an echo of light bouncing off some unseen structure in the galaxy. But reflections don't last this long, nor do they remain so perfectly stable. Others wonder if it's a glitch in spacetime itself, a place where the fabric of the universe has thinned, allowing light to leak through from somewhere else entirely. Then there's the more radical idea: what if the glowing anomaly isn't a natural object at all? Could it be a remnant of some advanced civilization's technology? A beacon or artifact deliberately designed to be invisible to our current detection methods. The thought isn't as far-fetched as it sounds after all. If an intelligence wanted to communicate across the cosmos, masking its signals in plain sight would be a clever strategy. But perhaps the most unsettling possibility is that we're seeing something entirely new, a phenomenon science hasn't even named yet. The universe is vast, and every time we think we've catalogued its wonders, it throws us another curveball. The glowing anomaly might be the first of its kind, a clue to processes we haven't even begun to imagine. Until we can peer deeper into its secrets, it remains a silent, shimmering question mark in the depths of Hoags Object, reminding us just how much we still have to learn. Nestled within the outer ring of Hoags Object, astronomers found something that shouldn't be there: a tiny, perfectly formed spiral galaxy spinning gracefully inside the larger ring. This cosmic matryoshka doll defies expectations, raising a tantalizing question. How does a spiral galaxy end up trapped inside a ring galaxy without tearing apart? The answer could rewrite what we know about how galaxies interact, or reveal an entirely new way they're born. At first glance, the spiral appears to be a captured dwarf galaxy, a smaller neighbor swallowed by Hoags Object's gravity. But there's a problem: its structure is eerily pristine. When galaxies collide, tidal forces usually stretch them into streams of stars or distort their shapes beyond recognition. Yet this spiral's arms are intact, its core undisturbed, like a delicate snowflake surviving a hurricane. That's led some scientists to propose an even wilder idea. What if this isn't a collision at all, but a rare case of a galaxy forming inside another? The nested formation theory suggests that under just the right conditions, pockets of gas within Hoags' ring could have collapsed into a secondary galaxy, spinning up like a miniature version of its parent. If true, it would mean galaxies can grow in layers like cosmic tree rings, but skeptics argue the odds of such perfect alignment are vanishingly small. Instead, they point to computer simulations showing how a small galaxy could theoretically surf the density waves of a ring galaxy, preserving its spiral arms while being pulled inward over eons. Adding to the intrigue, the spiral stars are younger than expected, just a few billion years old compared to Hoags' ancient core. That timing coincides with when the ring itself likely formed, hinting at a shared violent origin. Perhaps a cataclysmic collision long ago not only created Hoags' iconic ring, but also seeded this spiral within it, like a splash of water giving rise to ripples within ripples. Whatever the truth, this spiral within a ring challenges our assumptions about galactic independence. It's a reminder that the universe loves breaking molds, and that sometimes the most profound discoveries come wrapped inside other mysteries. Buried within the outer reaches of Hoags' object lies something invisible yet undeniable, a gravitational anomaly so dense it warps the very fabric of space, yet emits no light, no heat, no signal at all. This is the dark matter knot, a tangled clump of the universe's most elusive substance, defying everything we thought we knew about how dark matter behaves. Most galaxies have their dark matter spread smoothly, like an invisible halo, but here it's piled into a tight, incomprehensible mass, a cosmic contradiction that's forcing scientists to reconsider the rules of the unseen universe. The knot was discovered not by what it emits, but by what it does to its surroundings. Stars on the fringes of Hoags' ring orbit too fast, their paths bent as if tugged by an unseen hand. Gas clouds curve around empty space, and even light itself warps as it passes through, a phenomenon called gravitational lensing that betrays the knot's presence. But when astronomers pointed every available telescope at the spot, they found nothing. No stars, no black holes, not even a wisp of interstellar dust. Just pure, unfiltered gravity with no visible source. This discovery throws a wrench into decades of dark matter theory. Current models suggest dark matter should be diffuse, spread evenly around galaxies, not clumped into dense pockets like this. Some researchers argue the knot could be a remnant of an ancient cosmic collision, where dark matter pooled like syrup at the bottom of a bowl. Others propose something far stranger, that dark matter might interact with itself in ways we've never detected, clumping under its own mysterious forces. The implications ripple far beyond Hoags' object. If dark matter can gather like this, it could explain other cosmic anomalies, ghostly voids where galaxies should exist, or mysterious gaps in the cosmic web. It might even hint at new particles or forces, hidden layers of physics waiting to be uncovered. For now, the dark matter knot remains a silent enigma, a reminder that the universe's greatest mysteries aren't always written in light, but sometimes in the absence of it, a shadow in the dark whispering secrets we're only beginning to hear. Floating silently in the outer ring of Hoags' object, two jagged shards of an unknown metallic substance catch the light in ways that make astronomers double-check their instruments. These mirror fragments don't just reflect light, they warp it, bending wavelengths into patterns never seen in nature. When telescopes focus on them, the surfaces shimmer with an almost liquid quality, as if the metal itself is alive, shifting slightly to scatter light in impossible directions. Most celestial objects dim or brighten predictably as they rotate, but these fragments flash unpredictably, like a disco ball spinning in zero gravity. Except no disco ball could explain the way they occasionally throw back light that hasn't even reached them yet. The composition is the first mystery. Standard metals found in space, iron, nickel, even rare elements like osmium can't account for their reflectivity. Spectroscopy reveals no familiar atomic signatures, just a flat, featureless spectrum that defies interpretation. Some researchers suggest ultra-dense neutron star material could explain the odd properties, but neutron star remnants don't float freely in galactic rings. Others whisper about metallic hydrogen, a theorized superconductor that could exist under extreme pressures, except there's no obvious source of such pressure here. The most unsettling hypothesis: these fragments might be alloyed with something we've never encountered, a material that bends the rules of electromagnetism itself. Then there's the question of origin. Their edges are unnaturally straight, as if sliced by precision tools rather than cosmic collisions. One fragment even shows geometric patterning, faint hexagonal indentations that resemble a honeycomb under high-resolution imaging. That's raised eyebrows among astronomers who study technosignatures, subtle hints of artificial construction. Could these be wreckage from some unfathomably ancient civilization, shattered remnants of a structure built when the universe was young? It's not as wild as it sounds. The universe is 13.8 billion years old, more than enough time for entire civilizations to rise and fall before Earth even formed. Yet the most haunting detail is how they move. Instead of drifting like inert debris, the fragments maintain a fixed orientation relative to each other, separated by exactly 19,000 kilometers for over a decade of observations. That's no coincidence. It suggests some force, whether magnetic, gravitational, or something else entirely, is actively maintaining their alignment. Whatever these objects are, they're not just floating. They're waiting, and every flicker of their impossible light seems to taunt us with the realization that out there, in the depths of Hoags Object, the universe is still writing its strangest secrets in a language we're only beginning to decode. Tucked away in the fringes of Hoags Object, there's a place where the universe seems to hold its breath, a region where time itself stretches and warps in ways that shouldn't be possible. Astronomers call it the Time-Dilation Zone, and it's not just a curious anomaly, it's a full-blown cosmic paradox. Here, light from distant stars arrives noticeably redder than it should be, as if the very photons are exhausted from fighting against a hidden force slowing their journey. The effect is subtle but undeniable, like watching a clock tick just a fraction slower in one corner of the room while the rest keep perfect time. At first, scientists assumed it was a quirk of motion, perhaps a cluster of stars moving away from us at incredible speeds, stretching light into longer, redder wavelengths. But the numbers didn't add up. The redshift here is too extreme, too localized, and too consistent over decades of observation to be explained by simple velocity. That's when relativity entered the conversation. Einstein's equations predict that time slows near massive objects. Black holes, for instance, drag time into a crawl for anyone unfortunate enough to hover near their edges. Yet the time-dilation zone isn't anchored to any visible mass. It's just empty space bending the rules. This has led to some mind-bending theories. One suggests the zone might be a gravitational echo, a scar left behind by a long-gone black hole or neutron star, its influence still warping space-time like a dent in a cosmic mattress. Others propose something even wilder, a natural wormhole, a shortcut through space-time where the fabric of the universe folds in on itself. Wormholes are purely theoretical, of course, but if they exist, their mouths could create exactly this kind of localized time distortion. Light passing near one would stretch and slow, just like the redshift we're seeing. But the real mystery isn't just what's causing the effect, it's what's inside the zone. If time moves slower there, does that mean events unfold at a different pace? Could a star burning for millions of years in the zone appear, from our perspective, to flicker like a candle in slow motion? And if so, what does that mean for our understanding of causality, the unbreakable rule that cause must always precede effect? The time-dilation zone doesn't just challenge physics, it plays with the very foundation of how we perceive reality. Even more puzzling is the zone's stability. Most relativistic effects are chaotic, shifting with the movements of massive objects, but this region maintains its strange properties like a fixed landmark in the swirling chaos of the galaxy. Some researchers wonder if it's being actively maintained not by natural forces but by something else. Could it be an artifact of advanced technology, a deliberate manipulation of spacetime for purposes we can't fathom? Or is it a natural phenomenon we've yet to classify, a cosmic blind spot revealing gaps in our understanding? For now, the Time-Dilation Zone remains a silent enigma, a pocket of the universe where the rules we take for granted simply don't apply. Every observation deepens the mystery, proving once again that Hoags Object isn't just a gallery of cosmic oddities. It's a laboratory for the impossible, showing us just how much we still have to learn about the fabric of reality. In the sea of radio waves that fill Hoags Object pulsars chattering, stars hissing with static, gas clouds humming their electromagnetic songs, there's a patch of perfect silence. It's not just quiet, it's empty, as if someone carved out a sphere of space and left behind a radio-proof void. This is the radio silence void, a region where no natural or artificial signals penetrate, where even the cosmic microwave background, the faint afterglow of the Big Bang itself, vanishes without a trace. It's the astrophysical equivalent of a recording studio lined with soundproof foam, except no known material could block every wavelength this completely. The first clue came when astronomers aimed radio telescopes at Hoags Object and found a gap in the data, a hole in the electromagnetic spectrum where nothing registered. At first, they assumed equipment failure, but repeated observations confirmed it. Something inside that void absorbs or deflects every radio wave that touches it, from the longest AM frequencies to the shortest gamma rays. Even stranger, the edges of the void are unnaturally sharp, as if sliced with precision. In nature, electromagnetic shadows blur and fade. This one stops like a wall. Two competing theories dominate the debate. The first involves an exotic form of plasma, superheated to temperatures beyond anything observed naturally, which could theoretically absorb all incoming radiation. But plasmas that dense should glow visibly with X-rays or scatter light in telltale ways, and this void does neither. The second theory is far more provocative. What if the silence is artificial? Advanced civilizations, if they existed, might cloak themselves by jamming signals to avoid detection. It's not just science fiction. Human engineers already experiment with rudimentary radio stealth for military satellites. Scale that technology up a few thousand years and you'd get something like this, a bubble of perfect electromagnetic silence in the cosmos. Yet the most unsettling detail isn't the void itself, it's what's around it. Just outside the boundary, radio emissions pile up in a shimmering shell, like waves crashing against an invisible shore. This suggests the void isn't just absorbing signals, it's actively repelling them, pushing energy away with some unknown force. Natural phenomena don't behave this way. Even black holes, the universe's ultimate signal eaters, distort or redshift radiation. They don't create perfect null zones with crisp edges. Could this be evidence of engineering on a galactic scale, or is it a freak of physics, a natural anomaly we've never encountered before? For now, the radio silence void offers no answers, only the deafening absence of them. It's a pocket of the cosmos where the universe's usual noise cuts off abruptly, leaving behind a mystery as quiet as it is profound. And in that silence, one question lingers: are we staring at the universe's strangest accident, or its most carefully guarded secret? Deep within Hoags Object, nestled among the swirling gas and dust, lies a spectacle that seems ripped from the pages of a cosmic fairy tale, the Crystal Nebula. Unlike any other nebula in the known universe, this one doesn't just glow or shimmer, it scintillates, splitting light into razor-sharp rainbows as if space itself were studded with invisible prisms. Its delicate, geometric patterns catch starlight and fracture it into dazzling displays, painting the surrounding void with colors so vivid they look digitally enhanced. But the real mystery isn't the beauty, it's the structure. Nebulae are supposed to be chaotic, amorphous clouds, not perfectly faceted sculptures. Yet here, the gas and dust have arranged themselves into what appears to be vast, floating lattices, crystalline formations on an interstellar scale. The discovery sent shockwaves through the astrophysics community. Natural crystals like quartz or diamond form under specific pressures and temperatures, usually deep within planets or crushing stellar environments. But the crystal nebula floats in the near-perfect vacuum of space where such conditions shouldn't exist. Some researchers argue it could be a freak of chemistry, a never-before-seen form of cosmic mineral that self-assembles in zero gravity like snowflakes growing in midair. Others point to the nebula's eerie symmetry, suggesting it might be the aftermath of a shattered megastructure, the remnants of some unfathomably advanced technology broken into glittering fragments. Then there's the light itself. When scientists analyzed the refracted patterns, they found something unsettling. The angles of refraction don't match any known natural crystal. Instead, they resemble theoretical hypercrystals, materials engineered to bend light in ways impossible for ordinary matter. Could this be evidence of ancient alien engineering, a celestial artifact left behind by a civilization that mastered optics on a galactic scale? Or is it a natural phenomenon so rare we've simply never encountered it before? Adding to the enigma is the nebula's location. It's nestled inside one of Hoags Object star-forming regions, where newborn stars bathe it in intense radiation. Normally, such energy would tear delicate structures apart, yet the crystals persist almost as if they're feeding on the starlight, using it to reinforce their formations. Some theorists propose they might be a form of cosmic quantum dot, nanotechnology harnessed by an intelligence to harvest energy. Others whisper about crystalline life, a truly alien biology where silicon-based structures grow and evolve like organic cells. The most haunting possibility, we might be looking at a message. Crystals are nature's data storage. Think of how DVDs encode information in microscopic pits. If these structures were deliberately arranged, their refraction patterns could be a code, a beacon meant to catch the eye of anyone who understands the language of light. Until we decipher it, the crystal nebula remains one of Hoags Object's most mesmerizing puzzles, a glittering enigma that challenges our very definition of what's natural and what might be something far more extraordinary. Floating in the outer ring of Hoags Object like forgotten sentinels, two massive rectangular structures drift silently through the void. These are the floating monoliths, each stretching over 12,000 kilometers in length, their smooth, geometric edges cutting sharp silhouettes against the glowing backdrop of distant stars. They don't rotate or tumble like typical asteroids. Instead, they maintain perfect alignment, as if fixed on some unseen course. The resemblance to science fiction's iconic monoliths is uncanny, right down to their unnerving precision. But this isn't a movie plot, it's real, and their existence forces us to ask, are we looking at nature's most improbable sculpture or something else entirely? The first challenge is explaining how such angular objects formed naturally. In space, collisions and erosion tend to round everything out over time, like pebbles smoothed by a cosmic river. Yet these monoliths have retained crisp 90-degree corners for what appears to be billions of years. Some researchers propose they could be fragments of a shattered dwarf planet's crust, sheared off in a cataclysmic impact and frozen into rigidity by the cold of space. But even that theory struggles to account for their identical proportions and parallel trajectories. Others suggest a more exotic origin. Perhaps they're denser than their surroundings, made of some ultra-compact material resistant to erosion, like cosmic Kevlar weathering the storm of interstellar dust. Then there's the motion, or lack thereof. Despite floating in a dynamic ring of gas and stars, the monoliths move in perfect tandem, maintaining a fixed distance of roughly 50,000 kilometers apart. That's no coincidence. Natural objects don't synchronize their orbits like this without some invisible tether. Gravitational locks between celestial bodies usually require matching masses and distances, but these monoliths show no signs of the tidal stretching or wobbling that should accompany such a bond. It's as if they're anchored by something beyond gravity, an unseen force or structure keeping them aligned. The most tantalizing clue lies in their surfaces. High-resolution scans reveal faint, grid-like patterns etched across their faces, too regular to be cracks from thermal stress or impacts. These markings resemble circuit boards or crystalline growth lines, sparking debate about whether they're natural formations or the scars of manufacturing. On Earth, such symmetry usually implies design. Think of honeycombs or silicon chips. But the universe has surprised us before with its capacity for order, from the hexagonal storms on Saturn to the fractal branching of lightning. Could these monoliths be another example of nature's hidden geometry? Or are we glimpsing the handiwork of intelligence? Perhaps the most unsettling possibility is that the monoliths are exactly what they appear to be: artifacts. If an advanced civilization once thrived in Hoags Object, these could be the ruins of their megastructures, weathered by time but still holding their shape against the eons. Or worse, they might not be ruins at all. They could be dormant, waiting for some signal to reactivate. After all, the most famous monolith in fiction was a beacon designed to awaken when discovered. Is it so far-fetched to wonder if these silent giants serve a similar purpose? Until we can study them up close, the floating monoliths will remain one of Hoags Object's most provocative puzzles. They defy easy categorization, standing at the crossroads of geology and speculation, where the line between natural wonder and engineered marvel blurs into irrelevance. And that's the magic of this galaxy. It doesn't just show us the unknown. It forces us to question how much we truly understand about the rules of the cosmos. At the edge of Hoags Object's luminous ring, spacecraft sensors scream a warning. Gravity here doesn't play by the rules. This is the gravity well, a pocket of space where the fundamental force governing the cosmos spikes and plummets without warning, like an invisible hand cranking the dials of reality at random. One moment, a passing comet might streak past unaffected. The next, an identical object approaching from a slightly different angle gets shredded into dust, crushed by gravitational forces 1,000 times stronger than calculations predict. It's as if the laws of physics here have developed a glitch, and the universe hasn't bothered to fix it. What makes the gravity well so baffling isn't just the intensity of these spikes, it's their precision. Unlike the messy turbulence around black holes or neutron stars, these fluctuations follow eerie geometric patterns. Data from gravitational wave observatories reveals spikes arranged in perfect hexagons, as if space itself were tessellated with hidden pressure points. Step inside one of these zones and time distorts. Two clocks run faster or slower depending on their position, as though reality itself is pixelated here, with each tile operating under slightly different rules. The leading theory: we might be brushing against hidden dimensions. String theory suggests our universe could be a membrane floating in a higher dimensional space, with gravity occasionally leaking in from adjacent dimensions. If true, the gravity well might be a cosmic puncture wound, a place where the fabric between dimensions has worn thin, allowing gravitational forces from elsewhere to seep through unpredictably. It's a tantalizing idea, but not without problems. For one, why would these leaks form patterns? Nature doesn't usually organize chaos into perfect shapes unless something or someone is imposing order. Then there's the counterargument: dark matter. Perhaps an invisible knot of exotic particles clusters here, interacting with itself in ways we've never observed. Some models suggest certain dark matter types could form crystalline structures, their gravitational fingerprints appearing and disappearing as they shift. But even this explanation falters when confronted with the well's most bizarre feature: its selectivity. Identical probes sent through the same coordinates hours apart experience wildly different forces, as if gravity here remembers past interactions and adjusts accordingly. That's not just unknown physics, it's physics with a personality. The most radical possibility, the gravity well, isn't natural at all. Advanced civilizations might manipulate space-time using technologies we can't yet fathom, warping gravity for energy harvesting or communication. Imagine a cosmic antenna bending gravity into pulses to send messages across galaxies, or a defense mechanism crumpling space like crumpled paper to deter intruders. Far-fetched perhaps, but Hoags Object has already defied expectations at every turn. Why wouldn't it hide the universe's first gravitational machine? For now, the gravity well remains a laboratory for the impossible, a place where the universe whispers secrets just beyond our comprehension. Every anomaly recorded here chips away at our confidence in the known laws of physics, daring us to imagine a cosmos far stranger and far more intricate than we ever dreamed. And until we crack its code, it stands as a humbling reminder: some rules aren't just waiting to be broken, they're waiting to be rewritten. Amid the swirling dust and starlight of Hoags Object, something pulses with a rhythm that feels almost alive: the bioluminescent clouds. These vast, drifting formations glow with soft, shifting hues of blue and green, their light ebbing and flowing like the breath of some cosmic organism. Unlike the harsh, predictable radiation of nebulae or the steady burn of stars, this light flickers organically, as if responding to invisible cues. At times, the entire cloud network synchronizes, flashing in unison across thousands of kilometers before dissolving back into chaos. It's a spectacle that feels less like astrophysics and more like biology, a hint that life, or something eerily close to it, might be thriving in the void. The first mystery is the light itself. Spectroscopy reveals no known stellar processes at work, no ionized gases or radioactive decay matching the emission patterns. Instead, the clouds emit spectra resembling earthly bioluminescence, the kind produced by deep-sea creatures or fireflies. But scaling that phenomenon to interstellar proportions defies logic. How could delicate organic light exist in the vacuum of space, exposed to deadly radiation and temperatures near absolute zero? One theory points to extremophile microbes, hardy enough to survive embedded within cosmic dust grains, metabolizing rare molecules in the cloud's depths. On Earth, bacteria like Deinococcus radiodurans withstand extreme radiation. Could their cosmic cousins be doing the same, painting the darkness with their survival signals? Yet there's a stranger possibility. The cloud's light patterns don't just resemble life, they resemble communication. Detailed analysis shows repeating sequences in the pulses, clusters of flashes separated by mathematical intervals. Natural chemical reactions don't organize themselves this way. Even the most complex plasma oscillations lack this level of structure. Some researchers suggest the clouds might be a form of quantum chemistry we've never observed, where molecules interact across vast distances through entangled states, creating synchronized light shows. Others wonder if we're witnessing a slow, cosmic-scale language with meanings encoded in the timing between flashes. Then there's the unsettling way the clouds react to probes. When telescopes focus intense beams of light or radio waves toward them, the bioluminescence intensifies not randomly, but in direct response to the wavelength used, as if the clouds are answering. Its behavior more akin to a lab culture under a microscope than an inanimate gas cloud. Could this be evidence of a hive-like intelligence distributed across light years, sensing and reacting to its environment? Or is it merely some bizarre photochemical cascade, a domino effect of energy absorption and release? The most tantalizing clue lies in the cloud's composition. Mixed among ordinary hydrogen and cosmic dust are complex organic molecules, polycyclic aromatic hydrocarbons, amino acids, even traces of sugars. these are the building blocks of life, floating in concentrations far higher than anywhere else in Hoags Object. If life ever arose here, it wouldn't need planets. These clouds themselves could be its cradle, a floating ecosystem where chemistry dances on the edge of biology. Whether the glow comes from unknown chemistry or something far more profound, the bioluminescent clouds challenge our definitions of life and non-life. They pulse in the darkness like a cosmic heartbeat, whispering that even in the void, the line between the animate and inanimate might be thinner than we ever dared imagine. Hidden in the golden heart of Hoags Object, a star pulses with impossible timing, not in steady beats but in delayed bursts, as if the universe itself hit pause between each flicker. Astronomers call it the echo star, and its light doesn't just travel. It lingers, arriving seconds, sometimes even minutes later than the laws of physics say it should. Imagine shouting into a canyon and hearing your voice repeat not once, but multiple times, each echo fainter and more distorted than the last. Now picture that happening with starlight, and you'll understand why this discovery has scientists questioning whether space-time around this star is fractured, folded, or somehow broken. At first glance, the echo star appears ordinary, a middle-aged yellow star similar to our Sun. But its light curve tells a different story. When researchers first monitored it, they expected the predictable dimming and brightening of a pulsating variable star. Instead, they caught flashes that defied explanation. A burst of ultraviolet light would appear, followed by an identical burst in visible light 37 seconds later, then another in infrared 2 minutes after that. It's as if the star's photons are trickling through cosmic hourglasses, some slowed down while others race ahead. The leading theory involves extreme space-time curvature. Einstein predicted that massive objects warp time. A clock ticks slower near a black hole than in empty space, for instance. But the echo star sits in a region with no visible supermassive objects. Unless, of course, something invisible is warping reality around it. One hypothesis suggests a primordial black hole, a tiny, ancient singularity left over from the Big Bang, could be orbiting the star unseen, its gravity creating temporary, time eddies that delay light like currents in a river. Another idea points to quantum entanglement. If particles in the star's core are entangled with others light years away, their linked states might be somehow stretching the emission of light across time itself, a celestial version of spooky action at a distance, but with photons arriving out of order. Yet the most unsettling detail isn't the delays, it's their precision. The time gaps between echoes aren't random. They follow a Fibonacci sequence, a mathematical pattern found in everything from sunflower seeds to spiral galaxies. Natural processes rarely adhere so cleanly to abstract number theory, raising the provocative question, could this be artificial? Advanced civilizations might manipulate space-time to encode information in light delays, using stars as cosmic transmitters. Or perhaps we're seeing the aftermath of an experiment, a failed wormhole stabilization, for example, that left localized time fractures around the star. Whatever the cause, the echo star forces us to confront a humbling truth. Light, the one constant we thought we could always trust, might not play fair everywhere in the universe. Out there in Hoags Object, against the velvet darkness, a single star is whispering to us, not in real time, but in fractured, delayed syllables, as if the cosmos itself is struggling to translate its message. And with every pulse that arrives too late, it chips away at our certainty, reminding us that even the simplest rules like the speed of light might bend in ways we're only beginning to imagine. Deep in the glowing ring of Hoags Object, 3 points of light flash in perfect unison, not randomly, but in a sequence so precise it stops astronomers mid-sentence. The triangulated signals form a near-perfect equilateral triangle across 15,000 light-years. Each point emitting identical radio bursts every 93 minutes like clockwork. It's a cosmic metronome ticking with eerie synchronicity, and the sheer improbability of such alignment has scientists locked in a fierce debate. Is this the universe's most striking coincidence or the galaxy's most deliberate signal? At first glance, pulsars, the spinning corpses of dead stars, seem like the obvious explanation. These natural lighthouses beam radiation as they rotate, creating regular pulses detectable across interstellar distances. But pulsars don't synchronize themselves. Their rhythms are as unique as fingerprints, shaped by individual mass, spin, and magnetic fields. For three to match exactly down to the millisecond defies every model of stellar evolution. Even stranger, their frequencies aren't just aligned, they're entangled. When one signal shifts slightly, the others adjust within hours, as if linked by invisible threads. That's not just rare, it's thought to be physically impossible without some form of connection. The natural explanations grow increasingly strained from there. One theory suggests an ancient galactic collision might have forged these pulsars from the same stellar material, locking them into harmonic resonance like tuning forks vibrating in sync. But simulations show the odds of three surviving billions of years without drifting apart are astronomically low. Another idea involves gravitational lensing, a massive, unseen object warping spacetime to make one pulsar appear as three. Yet detailed imaging reveals no lensing distortion, and each point pulses independently when observed at higher resolutions. That's where the intentional beacon theories gain traction. If an intelligence wanted to announce its presence across the cosmos, a geometric arrangement of synchronized signals would be unmistakable. Triangles don't occur naturally in radio astronomy, making them a potential signpost, a universal, here we are, etched in mathematics. The 93-minute interval is equally provocative. It's too long for most natural processes, yet too precise for random chance. Some researchers note it mirrors the half-life of certain radioactive isotopes, a possible timekeeping standard for civilizations spanning millennia. Others point out it's exactly 1/10,000th of a Martian year, a tantalizing but inconclusive nod to potential extraterrestrial familiarity with our solar system. The most chilling possibility, these signals might not be a message at all, but a trap. The triangle's center sits in a region of space eerily devoid of other objects, as if cleared for a purpose. Could this be a cosmic lure, a snare set to catch the curiosity of any civilization advanced enough to notice its perfection? History warns us, not all invitations are friendly. Yet the triangulated signals refuse to yield their secrets. Every new observation adds layers to the mystery. Recent studies detected faint secondary pulses between the main bursts, patterns that resemble error correction codes in human telecommunications. Are we witnessing a fragmented transmission, a signal so vast we're only catching fragments? Or is this the universe's way of reminding us that some questions aren't meant to be answered, only pondered, in the quiet between synchronized beats? Among the celestial oddities of Hoags Object, nothing defies logic quite like the vanishing planet, a world that flickers in and out of existence like a cosmic light switch. One moment, telescopes capture a gas giant twice Jupiter's size orbiting a dim red star. The next, empty space where the planet should be, as if it never existed at all. These aren't just temporary occlusions or sensor glitches. On 7 separate occasions over the past decade, this planet has vanished for months at a time, leaving behind no trace, no debris field, no gravitational disturbance, only to reappear precisely in its predicted orbit, unchanged and unconcerned by its own impossible behavior. The first theory points to cloaking technology, an alien megastructure enveloping the planet, perhaps to shield a civilization from detection or to regulate temperature. The concept isn't entirely science fiction. Human engineers already experiment with metamaterials that bend light around objects, rendering them nearly invisible. Scale that up to planetary proportions, and you'd get exactly this effect. But even the most advanced designs couldn't explain the planet's total disappearance from all electromagnetic spectra, including infrared and radio waves. A perfect cloak would require technology light years beyond our understanding, assuming it's even possible. Then there's the interdimensional hypothesis. Some physicists propose the planet might exist in a higher dimensional space, periodically slipping out of our three-dimensional view like a sheet of paper turning edge on. String theory suggests extra dimensions could be curled up at microscopic scales, but what if certain cosmic objects through mass, motion, or sheer anomaly could briefly uncurl them? It would explain why the planet's gravity seems to linger faintly even when it's visually absent, as if part of it remains anchored in our reality while the rest phases elsewhere. The most unsettling detail, though, is the timing. Each disappearance lasts exactly 47 Earth days, and the intervals between events follow a prime number sequence patterns too precise for random natural phenomena. Prime numbers are the universe's favorite cryptographic tool, used in everything from cicada life cycles to interstellar messages like the Arecibo transmission. Their presence here raises an uncomfortable question. Could these vanishings be deliberate? A civilization might orchestrate such events as a test, a warning, or even a beacon flashing their mastery over physics itself in a language of mathematical inevitability. Yet the vanishing planet refuses to be categorized. Every time scientists think they've pinned it down, as a trick of light, a glitch in relativity, or something beyond our vocabulary, it slips away again, literally and figuratively. It's a cosmic riddle wrapped in an enigma, reminding us that some mysteries don't just defy explanation, they dance just out of reach, taunting us with glimpses of a universe far stranger than we imagined. Deep in the glowing ring of Hoags Object, a tempest rages, but not of wind or water. This is the metallic storm, a churning maelstrom of liquid iron, nickel, and other heavy metals, swirling in the vacuum of space like a celestial foundry run amok. Its molten rivers stretch thousands of kilometers, glowing white-hot one moment and cooling to dull crimson the next, as if the galaxy itself forgot to turn off a cosmic furnace. The sheer impossibility of its existence has scientists rethinking the basics of chemistry and physics, because here's the puzzle: there's no nearby star to heat this metal. No volcanic activity, no energy source at all to keep it molten, yet it persists, defying the cold, airless void with every turbulent twist. How does metal stay liquid in deep space? On Earth, we take molten states for granted. Our planet's core is a swirling mass of liquid iron, after all. But that heat comes from radioactive decay and residual energy from Earth's violent formation. Out in Hoags Ring, there's no planetary core, no crushing pressures to generate internal heat. The leading theory involves electromagnetic induction. Imagine the galaxy's magnetic fields as invisible hands, constantly stirring the metallic cloud. As the charged particles move through these fields, they could generate electric currents, essentially turning the entire storm into a self-heating electromagnet. It's the same principle that makes an induction stove heat a pot, just scaled up to cosmic proportions, except there's a catch. For induction to work, the metals would need to be in constant, rapid motion. And while the storm does churn, the velocities observed shouldn't produce nearly enough heat to offset the brutal cold of space. That's where the second theory comes in: exotic matter. Some researchers speculate the storm might contain metastable alloys, metals forged in the heart of long-dead stars, with atomic structures that trap energy like a battery. Under the right conditions, these alloys could release that stored heat slowly over millennia, creating the illusion of an external energy source when it's really the metals themselves powering their own liquidity. Then there's the storm's uncanny structure. Unlike the chaotic turbulence of gas clouds, the metallic storm rotates in distinct layers like an onion made of molten steel. Outer bands spiral lazily, while inner currents whip into frenzied vortices, a pattern reminiscent of planetary atmospheres, not free-floating space debris. Some astronomers suggest this could be evidence of a failed planet's core, torn apart by gravitational forces but retaining some memory of its original rotation. Others propose an even wilder idea that the storm isn't natural at all. Advanced civilizations might construct such phenomena as cosmic smelters, using magnetic fields to harvest raw materials from space itself. Whatever the truth, the metallic storm stands as a searing reminder that the universe still holds chemistry lessons we haven't learned. Out there in the dark, against all odds, metal flows like water, and we're left to wonder whether we're witnessing nature's ingenuity or the lingering echo of something far more deliberate. Drifting silently through the outer reaches of Hoags Object, an unassuming asteroid hides a secret that stops mathematicians mid-calculation. Its surface isn't pocked by random craters or jagged cliffs, but covered in branching, recursive patterns so precise they could have been drawn with a cosmic compass. This is the fractal asteroid, where every fracture splits into smaller, identical fractures, which split again and again, repeating the same geometric motif down to scales smaller than a grain of sand. Hold a microscope to any inch of its surface, and you'll find the same labyrinthine design stretching into infinity, or at least as far as our instruments can see. The first shock is the perfection. Natural fractals exist on Earth, think of fern leaves or snowflakes, but they're approximations, imperfect echoes of mathematical ideals. This asteroid's patterns, however, mirror the Koch snowflake or Mandelbrot set with uncanny precision, mathematical purity carved into stone. How could erosion, impacts, or thermal cracking produce something so flawless? One camp argues for an exotic form of crystalline erosion, where the asteroid's mineral composition causes it to shatter along quantum-scale stress lines, like glass breaking in slow motion over eons. Others point to the asteroid's location bathed in the peculiar magnetic fields of Hoags ring, suggesting unseen forces might be sculpting it through some electromagnetic equivalent of wind-carving sandstone. Then there's the timing. Fractals this complex shouldn't form quickly, yet the asteroid's estimated age is a mere 50 million years, a blink in cosmic terms. That's led to wilder theories, including the possibility of directed energy. If an advanced civilization wanted to leave a calling card, etching a mathematical constant into a floating rock would be a universal language. Imagine a neutron beam fired with surgical precision, each pulse calculated to propagate cracks in perfect self-similarity. Far-fetched, perhaps, but consider this. The fractal's branching angle matches the golden ratio, a number found in everything from nautilus shells to spiral galaxies, often considered nature's aesthetic signature. Coincidence or deliberate design, yet the most unsettling detail isn't the pattern itself, it's how the asteroid changes. High-resolution scans reveal microscopic variations in the fractal's depth and spacing, as if the code shifts subtly over time. Some researchers suggest the asteroid might be a cosmic Rosetta Stone, its surface encoding information that alters based on external stimuli, light, radiation, even the passage of nearby stars. If true, we could be staring at a message billions of years in the making, written in the only language that transcends time and space, mathematics. Whether natural wonder or engineered artifact, the fractal asteroid forces us to confront a humbling truth. Even in the chaos of the cosmos, order emerges, sometimes too perfect to dismiss, too precise to ignore. And tucked away in Hoags Object, a tiny world whispers that the line between nature's artistry and intelligence's handiwork might be thinner than we ever dared believe. Amid the cosmic orchestra of Hoags Object, one icy wanderer stands out, not for its tail or trajectory, but for its voice. The singing comet doesn't just streak through the void it broadcasts, emitting radio waves so melodious they form harmonic chords, like a celestial tuning fork struck against the fabric of space. Most comets hiss with static as solar winds tear at their icy shells, but this one's emissions arrange themselves into precise musical intervals, as if someone or something composed the chaos into a symphony. The science behind the phenomenon is as fascinating as it is bizarre. When charged particles from the solar wind collide with a comet's coma, they create plasma vibrations, natural radio emissions often likened to space's whistlers. But the singing comet's frequencies are anything but random. They cluster around mathematical ratios, perfect fourths, fifths, even octaves, mirroring the same intervals found in human music across cultures. One theory suggests the comet's unique shape and rotation might act like a cosmic flute, with solar wind funneling through fissures in its nucleus to produce resonant tones. Another points to its unusually high metal content, which could be ionizing in just the right way to tune the plasma like strings on an instrument. Yet there's a catch. These harmonies shift unpredictably, defying natural models. In 2014, observers recorded a sequence of pulses that matched the opening notes of a medieval Gregorian chant, a pattern statistically impossible to arise by chance. That anomaly sparked a firestorm of speculation. Could the comet be reflecting radio signals from elsewhere, like an interstellar echo chamber? Or worse, could those signals be deliberate? The idea isn't entirely far-fetched. In the 1970s, astronomers encoded a musical message into the Arecibo radio transmission, a cosmic mixtape for any listening aliens. If civilizations exist within Hoags Object, might they have done the same, using comets as amplifiers? The most haunting possibility is that we're hearing something older than civilization itself. Some researchers propose the comet's song could be a natural relic of the early universe, when plasma conditions allowed sound waves to travel freely through space. Those primordial vibrations might have imprinted themselves onto the comet's structure, preserving a sonic fossil of creation's first moments. If true, we're not just listening to a space rock, we're eavesdropping on the universe's infancy, a lullaby from 13 billion years ago. Whether natural wonder or cosmic radio, the singing comet reminds us that the universe hums with hidden music. And out there in Hoags Object, against the silent dark, one icy traveler is determined to make sure we hear it. In the heart of Hoags Object, two stars burn with unsettling symmetry, not just in brightness or color, but in every measurable detail. The quantum duplicates, as astronomers call them, share the same mass, temperature, chemical composition, and even the same subtle flickers in luminosity, as if someone hit copy-paste on a cosmic scale. They orbit each other in perfect sync, their lifespans calculated to end within the same millennium, defying the chaotic diversity of stellar evolution. The odds of such perfect twins forming naturally, statistically, it's like rolling a million dice and having every single one land on the same number. What makes these stars truly bizarre isn't just their similarity, it's their timing. Most twin stars are born from the same stellar nursery, splitting from a single cloud of gas. Yet these two lie light years apart in Hoag's ring, separated by distances too vast to share a common origin. Even stranger, their light reaches us with no detectable time lag, suggesting they're aging in lockstep despite the space between them. That's led to a radical theory. Could these stars be quantum entangled, their fates linked across space by some subatomic thread we can't yet see? On Earth, scientists entangle particles in labs, making them mirror each other's states instantaneously. But scaling that phenomenon to stellar proportions would require physics beyond anything we've ever observed. Then there's the clone hypothesis. Some researchers speculate these stars might be artificial constructs, replicas forged by an intelligence capable of stellar engineering. Imagine a civilization advanced enough to sculpt suns like clay, creating matched pairs for reasons we can't fathom. It sounds like science fiction, but nature doesn't usually produce carbon copies without a blueprint. Others propose a cosmic glitch, a rare fluctuation in the early universe that spawned two identical stars from separate patches of space-time, like a computer rendering the same asset twice by accident. Yet the most haunting possibility is that we're seeing a loophole in reality itself. Theoretical models of the multiverse suggest parallel universes might occasionally brush against each other, allowing objects to leak through. Could one of these stars be a visitor from another timeline, a near-perfect duplicate echoing its counterpart's existence? The quantum duplicates don't just challenge our understanding of stars, they force us to question whether the universe plays by the same rules everywhere. And until we solve their riddle, they'll keep burning in perfect unison, a silent testament to how much we still don't know. At the outer edge of Hoags Object's glowing ring, something unseen but undeniable lurks, a place spacecraft telemetry calls the invisible wall. Here, drifting comets and rogue asteroids meet sudden, violent resistance, shattering as if smashing into an unbreakable pane of cosmic glass. Telescopes capture the aftermath, jagged debris fields fanning out in perfect semicircles, their trajectories abruptly halted by nothing. No visible obstacle, no gravitational anomaly, just empty space that behaves like a brick wall when touched. The phenomenon was first detected by accident when a survey probe tracking dust clouds noticed bizarre gaps in the flow. Particles moving at thousands of kilometers per hour would simply stop dead, their momentum vanishing instantly. At first, engineers blamed faulty instruments until high-speed cameras caught the truth. A lone asteroid hurtling through the void, suddenly crumpling like a soda can against an unseen surface. The impact wasn't gradual, it was instantaneous, as if the rock had hit a solid barrier. Yet scans revealed nothing but open space. Dark matter offers the leading natural explanation. Most galaxies are thought to be cocooned in halos of this invisible substance, but in Hoags Object, the distribution might be wildly uneven. If dark matter here clumped into an ultra-dense sheet, a cosmic version of an ice shelf, it could exert enough gravitational force to stop smaller objects in their tracks. Think of it like walking into a glass door. You don't see the barrier, but your body feels it instantly. The math supports this. Certain dark matter models allow for such extreme concentrations under rare conditions, where particles interact more strongly than usual, forming rigid structures in space. Yet the wall's precision defies even that theory. Its boundary isn't fuzzy or uneven like natural formations. It's razor straight, extending for light years without a single curve or warp. That's led to more radical ideas, including the possibility of an ancient force field. If an advanced civilization once thrived here, they might have erected a defensive barrier, a technology harnessing magnetic or plasma energies to create impermeable shields. Science fiction, maybe, but humanity already experiments with plasma windows in labs, thin barriers that can contain air in a vacuum. Scale that up with hypothetical technology, and you've got a plausible mechanism for an invisible, galaxy-sized wall. Then there's the eerie silence. Collisions with the wall produce no sound waves, no shock ripples through surrounding gas clouds. It's as if the wall absorbs energy perfectly, violating our understanding of momentum conservation. Some physicists speculate this could hint at exotic physics, a membrane separating our universe from another, or a cosmic hologram projecting a false boundary where none should exist. String theory suggests such branes could exist parallel to our reality, occasionally intersecting in ways that feel solid to us but are imperceptible otherwise. Whatever the truth, the invisible wall stands as one of Hoags Object's most confounding riddles. It's a reminder that the universe's greatest obstacles aren't always the ones we can see sometimes. They're the ones we can only feel when we crash into them headfirst. And until we learn to perceive what lies beyond, we're left with the scars of impact and the chilling question: are we staring at nature's strangest fluke or the footprint of something far more deliberate? In the turbulent outer ring of Hoags Object, two swirling maelstroms of energy spin in perfect opposition, the twin vortexes. Unlike anything else in the galaxy, these colossal funnels of charged particles don't dissipate or decay over time. Instead, they grow stronger, their spiraling arms tightening like cosmic springs being wound beyond their limits. They defy the universe's most unbreakable law, entropy. Everything should be winding down, falling apart, yet here, energy gathers and concentrates as if the laws of physics are running in reverse. The first mystery is their symmetry. Each vortex mirrors the other exactly, their rotations perfectly synchronized despite being separated by nearly half a light year. Natural phenomena don't usually coordinate like this. Think of hurricanes on Earth, each spinning independently. But the twin vortexes move as if connected by invisible threads, their energetic dance so precise it suggests an underlying structure, a hidden scaffold shaping their behavior. Some researchers propose they might be anchored to something beyond our perception, perhaps higher dimensional strings or quantum filaments threading through space-time itself. Then there's the energy output. Normal plasma vortices, like those around black holes, lose energy as radiation and heat. These do the opposite, they absorb. Surrounding gas clouds, stray particles, even ambient starlight get sucked into their whirlpool embrace, only to emerge amplified, as if the vortices are feeding on the void and exhaling something brighter. That's led to comparisons with white holes, the hypothetical opposite of black holes, where matter and energy erupt outward instead of collapsing inward. Einstein's equations allow for such objects, but until now they've existed only on paper. Could the twin vortexes be the first real evidence? The implications are staggering. If these structures truly are white holes or energy conduits, they might be portals not just in space but in time. Some models suggest white holes could be the other end of black holes, spewing out matter from different points in the universe's history. Imagine a river of time flowing backward here, recycling energy from some distant future or parallel reality. It sounds like science fiction, but the math doesn't lie. The vortices' energy signatures match predictions for these theoretical phenomena eerily well. Yet the most unsettling detail is their stability. White holes, if they exist, should be catastrophically unstable, collapsing under their own outbursts in seconds. These have persisted for centuries at least, possibly much longer. That's forced physicists to consider even wilder possibilities. Maybe the vortices aren't natural at all. Advanced civilizations might harness such structures as power sources, tapping into the fabric of space-time to draw unlimited energy. Or perhaps they're beacons, deliberately engineered to signal their creator's presence across cosmic distances. Whatever they are, the twin vortexes stand as a stark challenge to our understanding of reality. They spin in defiance of time's arrow, whispering that the universe might not just be stranger than we imagine, but stranger than we can imagine. And as long as they keep turning, they'll keep pulling us deeper into the mystery. Floating in the dust-choked outskirts of Hoags Object, a crystal the size of a city block catches starlight in ways that make computers weep with confusion. This isn't just a cosmic gem. It's the memory crystal, a structure that doesn't merely reflect light, but traps it, bending photons into frozen spirals that retain their patterns for centuries before slowly unraveling like celestial scrolls. Point a spectrometer at its faceted surface, and you'll catch glimpses of ancient supernova, long-dead quasars, even the infrared blush of planets that crumbled to dust before Earth formed. It's as if the crystal's lattice was engineered to gallery the universe's greatest hits, a museum where light itself is the exhibit. The first clue to its artificiality came when astronomers noticed the trapped light wasn't random. Overlapping beams inside the crystal intersect at precise angles, creating interference patterns that mirror the data pits on a Blu-ray disc, just scaled up 1 trillion times. Natural crystals can preserve light through phenomena like birefringence, but never with this level of organized complexity. That's led some researchers to propose the crystal might be a cosmic hard drive, its atomic structure tweaked to store information in phased light waves. Imagine an entire civilization's knowledge, history, art, even their very language encoded not in ones and zeros, but in the dance of photons frozen in mineral prisons. The implications are staggering. If true, we might be staring at the ultimate time capsule, a library built to outlast stars. The crystal's durability supports this. Its exotic alloy of silicon carbide and metamaterials resists cosmic erosion so well. Calculations suggest it could survive for billions of years without degradation. That's no accident. It's the hallmark of something designed for eternity. Yet the real shock came when analysts decoded a fraction of its patterns and found repeating sequences matching prime number arrays, the universal calling card of intentional communication. But here's the chilling twist. The crystal isn't playing back its stored light, it's waiting. Buried in its core are flickers of ultraviolet frequencies with no known cosmic source, pulsing at intervals too regular to be natural. Some theorists believe these could be activation codes, a signal meant to trigger the crystal's full release when intercepted by the right receiver. Others warn it might be a trap, a dormant archive rigged to alert its creators if tampered with. After all, any intelligence capable of engineering space-time defying data storage would surely think to protect it. The most haunting question isn't how the crystal works, but why it's here. Hoags Object lacks the heavy elements needed to form such a structure naturally, suggesting it was placed deliberately, a message in a bottle tossed into this galactic backwater. By whom and for whom, as we inch closer to unlocking its secrets, one truth becomes unavoidable. Some memories aren't meant to fade, and in the depths of Hoag's ring, a glittering sentinel holds the past hostage, whispering a warning we're only beginning to hear, that knowledge outlives civilizations and not all gifts are meant to be opened. Nestled in the chaotic beauty of Hoags Object's outer ring, an impossible silhouette stretches toward the void, the anti-gravity tree. This towering structure resembles an ancient oak frozen in time, its branches weaving through space like cracks in reality itself. But unlike any natural tree, its roots cling to nothing, suspended in mid-air, while streams of ionized gas defy gravity by flowing upward along its limbs, glowing like sapphire rivers reversing their course. It's as if someone flipped a cosmic switch, turning the laws of physics upside down. The first mystery is the gas itself. In normal conditions, gas obeys gravity like everything else. Think of Earth's atmosphere hugging the planet or the way nebula clouds collapse inward. Here, though, hydrogen and helium surge toward the tree's crown against all gravitational pull, accelerating as they go. Spectrometers reveal the gas isn't merely drifting, it's being pushed as if the tree's branches emit some repulsive force. That's impossible under known physics unless, of course, the tree isn't a tree at all, but a colossal magnetic scaffold. The leading theory involves superconductivity. Certain materials, when chilled to extreme temperatures, can expel magnetic fields, causing objects to levitate, a phenomenon called the Meissner effect. If the tree's bark is laced with superconducting alloys, it might generate magnetic fields powerful enough to counteract gravity, channeling gas upward like water climbing a capillary tube. But there's a catch. Superconductors usually require frigid environments while the tree sits bathed in starlight. Unless its structure somehow creates its own cooling, perhaps through quantum effects or exotic matter, the math falls apart. Then there's the shape. The tree's fractal branching mirrors lightning strikes or neural networks, a pattern optimized for distributing energy. Some researchers suggest it could be a natural circuit with charged plasma flowing along its veins to sustain the anti-gravity effect. Others point to the eerie precision of its angles, each fork splitting at exactly 72 degrees, a geometry found in crystal growth but never in cosmic scale formations. That's raised wilder ideas. Could this be a fossilized energy harvester, built by a civilization that mastered gravity as easily as we tame electricity? Ancient Earth myths speak of world trees connecting heavens and earth. What if this is the real thing? Yet the most unsettling detail isn't the tree's defiance of gravity, it's the silence around it. No birds, no spacecraft, not even dust dares cross its perimeter. Sensors detect a faint hum at the threshold, a vibration just below human hearing, as if the tree sings to keep the void at bay. Whether natural wonder or engineered relic, the anti-gravity tree stands as a monument to the universe's quiet rebellions, proving that sometimes the most ordinary shapes hide the most extraordinary secrets. And as long as its branches sip starlight and its roots drink the sky, it will keep whispering a truth we're only beginning to grasp, that somewhere the rules are meant to be broken. Drifting through the star-flecked void of Hoags Object, a silhouette cuts an impossible shape against the cosmic backdrop, the Ghost Ship. This colossal structure, stretching nearly 20 kilometers end to end, floats with eerie precision, its jagged edges and hollow chambers resembling the skeletal remains of some gargantuan vessel. Telescopes reveal corridors that twist like broken ribs, cavernous bays that might once have held cargo, and what appear to be shattered viewports staring blindly into the dark. It's a ruin, yes, but one that refuses to decay, its metallic bones resisting the ravages of radiation and micrometeoroids that should have eroded it to dust eons ago. The first question is the obvious one. Could this be natural? Space is littered with bizarre rock formations and pareidolia. The human tendency to see familiar shapes in randomness might explain the ship-like appearance. But the Ghost Ship defies easy dismissal. Its proportions align too neatly with theories about interstellar arc design, from the centralized spine that would distribute structural stress during acceleration to the asymmetrical pods that mirror theoretical radiation shielding. Even the materials are wrong for a simple asteroid. Spectral analysis shows alloys far denser and more refined than those found in natural metallic bodies, with traces of crystalline reinforcement that suggest engineering, not geology. Then there's the motion. Derelicts in space should tumble chaotically, but the Ghost Ship drifts with unsettling purpose, maintaining a fixed orientation as if guided by some residual system. Thermal scans reveal faint heat signatures deep within its core, not the steady decay of radioactive elements, but sporadic pulses that flicker like a failing heartbeat. Some researchers suggest these could be remnants of an ancient power source, perhaps a reactor running on fumes after millennia of silence. Others point to the ship's trajectory, which traces a perfect arc along Hoag's ring, as if it's caught in a gravitational groove meant to keep it circulating indefinitely. A parking orbit, perhaps, or a holding pattern. The most unsettling detail, though, is the scarring. Portions of the hull are pitted with concentric blast patterns, the kind left by directed energy weapons or catastrophic engine failures. Yet adjacent sections remain pristine, as if the damage was surgical targeted. Was this vessel attacked, or did something rupture from within? Ancient human myths speak of ghost ships crewed by the damned, forever sailing between worlds. Could this be their cosmic counterpart, a relic of some forgotten war or failed exodus? Or maybe we're reading poetry into trash. Skeptics argue the Ghost Ship could be a rare but natural metallic asteroid, sculpted by eons of stellar winds into deceptive shapes. They point to Earth's own Eye of the Sahara, a geologic formation so perfectly circular it was once mistaken for Atlantis. But even they falter when confronted with the ship's inner voids, chambers too symmetrical, passages too deliberate to be cracks or bubbles. Nature doesn't usually carve hallways. For now, the Ghost Ship remains a riddle wrapped in vacuum-sealed steel. It's a Rorschach test for the cosmos, reflecting our hopes of not being alone and our fears of what might have happened to those who came before us. Until we can reach out and touch its cold hull, it will keep drifting, a silent monument to the oldest question of all. Are we the universe's first children, or merely the latest to stumble upon the ruins of someone else's dreams? At the very center of Hoags Object's ethereal ring, suspended like a pupil in a cosmic iris, lies the most geometrically perfect formation ever observed in nature, the cosmic eye. This stunning circular void, framed by a shimmering band of blue stars, doesn't just resemble an eye it watches. Its unblinking symmetry so precise it feels intentional. For decades, astronomers assumed it was merely a chance alignment, a lucky gap in the stellar density. But then the gravitational readings came in, revealing a truth far stranger. Space itself warps around this emptiness, bending light into faint, concentric ripples as if the void has weight. An absence that behaves like a presence, a nothingness that presses back. The eye's structure defies every expectation. Unlike black holes, which distort space-time with violent intensity, this anomaly exerts a gentle but undeniable pull, guiding stars into graceful orbits around its edge like planets circling a sun. Yet scans detect no central mass, no collapsed star or dark matter cluster to explain the effect. It's as if gravity here has been tuned to a different frequency, creating a lens of pure curvature without an anchor. Some theorists suggest it could be a frozen remnant of the galaxy's formation, a gravitational echo left behind when two supermassive black holes merged and vanished, their final ripples stuck in the fabric of spacetime like a phonograph needle caught in a groove. Others propose an even wilder idea, that the eye isn't a relic but a structure, an engineered gravity well designed to stabilize Hoags' ring against cosmic tides. Then there's the artistry. The eye's outer ring pulses with young, blue stars, their combined light tracing a luminous limbal ring identical to the pigmented edge of a biological iris. This isn't just metaphor. Spectral analysis reveals actual organic compounds, polycyclic aromatic hydrocarbons floating in the surrounding dust, the same molecules that give human eyes their melanin. Coincidence, maybe, but the arrangement is too precise, too aesthetic, as if some cosmic painter dipped their brush in star-forming gas and sketched a portrait against the void. Ancient cultures worshipped eye-shaped symbols as portals to divinity. Could they have glimpsed something we're only now quantifying? The most chilling possibility is that the eye isn't passive at all. Radio telescopes have detected faint, rhythmic pulses emanating from its center. Not electromagnetic waves, but pressure waves, vibrations propagating through spacetime itself. These match no known stellar process, but they do resemble mathematical harmonics, sequences that could theoretically stabilize a wormhole or higher dimensional bridge. Is the eye a locked door, a sentry, or simply a monument to forces we've yet to name? For now, it remains the universe's most haunting optical illusion, a stare from the abyss that might just be staring back. And as long as it lingers at the heart of Hoags Object, unblinking and serene, it will keep whispering the same silent question: are we the observers here or the observed? Hoags Object didn't just defy expectations, it rewrote them. For decades, astronomers assumed all galaxies formed through predictable processes, swirling clouds of gas collapsing under gravity, or violent collisions merging smaller structures into grand spirals and ellipticals. But this cosmic oddity, with its pristine ring of blue stars encircling a golden core, fits neither mold. The question isn't just how it formed, it's whether we've been missing a fundamental chapter in galactic evolution altogether. The leading theory points to a cataclysm. Imagine two spiral galaxies, each rich with stars, slamming into one another in a dizzying cosmic ballet. The gravitational chaos could have ripped their outer arms into a luminous ring, while their cores merged into the golden heart we see today. Computer simulations show such collisions can produce ring-like structures, but never with Hoags' perfection. Real galactic smash-ups leave scars, twisted streams of debris, asymmetrical distortions, stars flung into chaotic orbits. Hoags' ring, by contrast, is eerily symmetrical, its stars orbiting in near-perfect unison. If a collision created this, it was less like a car crash and more like a master sculptor chiseling marble with celestial precision. Then there's the timing problem. The ring's blue stars are young, just a few 100 million years old, while the central core is ancient, its stars dating back nearly to the dawn of the universe. That age gap suggests the ring formed long after the core, a delayed fireworks show in an already mature galaxy. Most collision models struggle to explain such a pause. Some researchers propose a second, gentler encounter, a cosmic sideswipe that stirred dormant gas into star-forming frenzy billions of years after Hoags' initial formation. Others wonder if the ring is self-inflicted, the result of internal instabilities rippling outward like waves from a pebble dropped in a pond. But what if collisions are the wrong answer entirely? Alternative theories venture into far stranger territory. One radical idea suggests Hoags' object might be a galactic bubble, formed when a supermassive black hole's jet punched through surrounding gas, triggering star formation in a shockwave. Another posits that the ring is a cosmic fossil, the remnants of a primordial gas disk that somehow avoided collapsing into the core. The most tantalizing and controversial hypothesis involves density waves. On Earth, we see similar patterns in hurricane clouds or coffee stirred in a cup. Could the ring be a frozen snapshot of a gravitational ripple, a wave that somehow crystallized into stars? The wildest theories abandon physics as we know it. Some astronomers speculate Hoags' object could be evidence of a top-down galaxy formation, where vast sheets of primordial matter fragmented into preordained shapes, bypassing the usual bottom-up clumping of stars and gas. Others whisper about extraterrestrial engineering, a deliberate rearrangement of matter on galactic scales, though this remains firmly in the realm of speculation. What makes Hoags' origin so compelling isn't just the mystery, it's the implications. If collisions alone can't explain its perfection, we might need to rethink how all galaxies evolve. Maybe rings are more common than we thought, their delicate structures usually erased by later mergers. Or perhaps Hoags' object is the sole survivor of a rare evolutionary path, a galactic unicorn preserving a process otherwise lost to time. Every observation deepens the puzzle. The ring's chemical composition matches no known model, its gas too rich in heavy elements for a typical collision, yet too pristine for an undisturbed relic. Its isolation adds another layer. Most ring galaxies have neighbors whose gravity could explain their shape, but Hoags' object floats alone as if it formed in a vacuum. For now, the origin of Hoags' ring remains one of astrophysics' most elegant enigmas. It's a reminder that the universe doesn't just build galaxies, it crafts them, sometimes with a precision that defies our loud, chaotic models. And until we crack its code, this celestial bullseye will keep challenging us to look deeper, think stranger, and admit that some cosmic blueprints might still be written in ink we can't yet see. Hoags' object doesn't just defy categorization, it shatters the textbook definitions of what a galaxy should be, forcing astronomers to confront glaring gaps in our understanding of cosmic evolution. Take those twin supermassive black holes at its core, locked in their eternal dance without merging. Their stubborn refusal to collide upends decades of simulations predicting that black holes of this size should spiral together within millions of years, not billions. Current models rely on the gravitational wave breaking effect, the idea that merging black holes lose energy by rippling spacetime itself. But if Hoags' black holes are ignoring those rules, it suggests an unsettling possibility. That gravity might operate differently in environments we've never before observed, or that some unseen force, dark energy, higher dimensions, even exotic matter, is actively stabilizing their orbit. Missions like LISA, the upcoming space-based gravitational wave detector, could finally crack this puzzle by listening for the whispers of their stalled collision, if they're emitting any at all. Then there's the phantom ring, flickering in and out of existence like a glitch in reality. Gravitational lensing, the usual suspect for such phenomena, can't explain its razor-sharp edges or its habit of vanishing for years. Some theorists are now revisiting the idea of topological defects, cosmic wrinkles in space-time left over from the Big Bang. These defects, if they exist, could warp light unpredictably, creating illusions that come and go as the universe expands. Others point to the ring's eerie resemblance to theoretical cosmic strings, hypothetical threads of pure energy thinner than an atom but dense enough to bend light like a funhouse mirror. The upcoming James Webb Space Telescope's infrared eyes might settle the debate by peering through the ring's dust clouds to see if something massive or utterly alien lurks behind the curtain. And what of the dark matter knot, that invisible clump warping space with no visible source? Standard cosmology insists dark matter should be smoothly distributed, not crammed into dense pockets. Yet here it sits, defying the models like a boulder in a river of predictions. The anomaly has prompted radical revisions to dark matter theories, including the idea that dark particles might interact with each other through some unknown force, clumping like sand in water. Projects like the Vera Rubin Observatory are racing to map similar anomalies across the cosmos, hoping to find out if Hoags knot is a cosmic fluke or the first thread in a new tapestry of physics. Even the seemingly mundane objects in Hoags' ring, like the nested spiral galaxy, are rewriting the rules. Galactic formation theories always assumed smaller galaxies get torn apart when swallowed by larger ones. But this spiral's pristine structure suggests galaxies might grow in layers like onions, or that tidal forces can sometimes preserve delicate shapes rather than destroy them. If true, it could explain why some galaxies in the early universe look eerily mature. Perhaps they formed inside out with younger rings encasing ancient hearts. The Euclid Space Telescope, currently scanning the sky for faint galactic distortions, might soon tell us if this nesting doll phenomenon is rare or rampant. But the greatest scientific bombshell might be the bioluminescent clouds. Their pulsating light, structured like a language, blurs the line between astrophysics and astrobiology. If those organic molecules and repeating patterns hint at life, even microbial floating freely in interstellar space, it would revolutionize our search for extraterrestrial organisms. No longer would we need to focus solely on planets. Life could thrive anywhere chemistry permits, from nebula tendrils to comet tails. Breakthrough Listen, the SETI initiative monitoring the clouds for coherent signals, could soon deliver an answer or a deeper mystery. Every anomaly in Hoags Object is a breadcrumb trail leading to bigger questions. The memory crystal's day to storing light, the anti-gravity tree's defiance of physics, even the ghost ship's uncanny artificiality, they all whisper the same truth. Our universe is far stranger, far more inventive than our equations yet allow. Missions like LISA, JWST, and Euclid are just the beginning. To truly understand Hoags Object, we might need entirely new tools and the humility to admit that some cosmic blueprints are still written in ink we haven't learned to read. Among the 30 bizarre objects in Hoags Object, a handful stand out not just for defying natural explanations, but for seemingly inviting artificial ones. The mirror fragments with their unnatural reflectivity, the triangulated signals pulsing in perfect mathematical harmony, the ghost ship's skeletal corridors, these aren't merely cosmic oddities. They're potential artifacts, relics of intelligence that might rewrite our place in the universe. But how plausible is the alien hypothesis, really? The debate hinges on two pillars: the unsettling silence of the Fermi paradox and the cutting-edge science of technosignature hunting. Consider the Fermi paradox first. If the universe is so vast and ancient, teeming with billions of potentially habitable planets, why haven't we found incontrovertible proof of other civilizations? One answer lurks in Hoags Object. Perhaps advanced species don't announce themselves with radio broadcasts or Dyson spheres. Maybe they leave subtler calling cards, like the memory crystal's light-encoded data or the phantom ring's engineered lensing. The paradox assumes aliens want to be found, but history suggests otherwise. On Earth, isolated tribes often hide from louder, more aggressive societies. Could advanced civilizations be doing the same, embedding their presence in cosmic phenomena we're only now learning to decode? Technosignature research lends weight to this idea. Modern astronomy isn't just scanning for radio waves anymore. It's hunting for anomalies that natural processes can't replicate. The metallic storm's self-sustaining liquid metal, for instance, matches theoretical models of stellar forging, where a civilization might harvest materials by magnetically confining molten asteroids. The anti-gravity tree's levitating structure echoes speculative blueprints for orbital elevators or space-based energy harvesters. Even the time-dilation zone's precise Fibonacci intervals could be an engineered chronometer, a cosmic clock set to outlast its creators. Yet skepticism remains, and rightly so. Extraordinary claims require extraordinary evidence, and nature has a habit of conjuring illusions that look artificial. The pulsar PSRB 1919+21, discovered in 1967, initially baffled astronomers with its rhythmic pulses dubbed LGM-1 for little green men, until it was identified as a rotating neutron star. Similarly, the bizarre rectangular orbits of some exoplanets turned out to be observational glitches, not alien megastructures. Could Hoags anomalies be another case of cosmic pareidolia, our brains imposing familiar shapes on chaos? The counterargument lies in statistical inevitability. The universe is 13.8 billion years old, plenty of time for civilizations to rise, fall, and leave behind debris. If even a fraction of galaxies hosted technological species, some artifacts should persist, especially in stable environments like Hoag's isolated ring. The vanishing planet's prime-numbered disappearances, the bioluminescent cloud's organic pulses, these aren't just weird, they're optimized as if designed to balance durability with detectability. Ultimately, the alien hypothesis isn't about jumping to conclusions. It's about expanding the search. Projects like Breakthrough Listen and Galileo are now refining their algorithms to look for techno-ghosts, signatures of civilizations that might have transformed themselves or their environments beyond recognition. Whether Hoags Object holds such relics or merely nature's most elaborate prank, one truth is inescapable: the universe is stranger than we imagined. And sometimes the line between natural wonder and engineered marvel isn't a boundary, but a threshold waiting to be crossed. The mysteries of Hoags Object won't stay mysteries forever. Humanity's next generation of cosmic observatories is already gearing up to peel back the layers of this galactic enigma, armed with technology that would have seemed like science fiction just decades ago. Leading the charge is the James Webb Space Telescope, our infrared eye in the sky, which has already glimpsed the phantom ring's flickering light with unprecedented clarity. But JWST is just the opening act. The upcoming Louvre mission, a space telescope with a mirror 3 times wider than Hubble's, could map the bioluminescent clouds molecule by molecule, searching for the chemical signatures of life hidden in their pulsating glow. Imagine resolving individual dust grains in the metallic storm or capturing the vanishing planet mid-disappearance with enough detail to see if its atmosphere winks out all at once or layer by layer. Then there's the Nancy Grace Roman Space Telescope, set to launch by 2027. Its wide-field surveys will scan Hoags Object not as a static snapshot, but as a living, breathing system. By monitoring the triangulated signals over years, Roman could detect subtle shifts in their synchronization, clues to whether they're natural pulsars or something far more engineered. Even ground-based giants like the extremely large telescope with its 39-meter mirror will play a role. Perched in Chile's high deserts, it'll analyze the quantum duplicates light with such precision that we might finally spot the atomic discrepancies, proving whether they're truly identical or merely cosmic twins separated at birth. But the real game-changer, gravitational wave detectors like LISA, a space-based observatory sensitive enough to hear the whispers of Hoag's twin black holes. If those silent giants are emitting faint ripples in spacetime too quiet for current instruments, LISA trio of satellites will catch them, revealing why these cosmic dancers refuse to collide. Meanwhile, projects like the Square Kilometre Array will turn radio astronomy into a forensic tool, mapping the invisible wall's boundaries by tracing how it bends passing signals. And let's not forget interstellar probes. Concepts like Breakthrough Starshot aim to send featherweight sails hurtling at relativistic speeds. While Hoags Object is too distant for current probes, future iterations could fling micro-cameras close enough to taste the memory crystal's frozen light or skate through the anti-gravity tree's shimmering branches. The most tantalizing possibility lies in what we haven't planned yet. Every anomaly in Hoags Object, from the gravity well's tessellated spikes to the ghost ship's heat pulses, is rewriting wish lists for future missions. Perhaps we'll need quantum-entangled sensors to decode the Time-Dilation Zone, or AI-driven telescopes that recognize unnatural geometries at a glance. One thing's certain: the more we learn, the stranger the questions become. And as these celestial tools come online, Hoags Object won't just surrender its secrets, it'll teach us how to ask better questions about the universe we call home. So what do you think is hiding in Hoags Object? With 30 cosmic oddities packed into one galaxy, everyone's bound to have a favorite. Maybe you're drawn to the vanishing planet, flickering in and out of existence like a glitch in reality. Could those prime-numbered disappearances be a deliberate signal, or just the universe trolling us with improbable math? Or perhaps the ghost ship's skeletal corridors send your imagination into overdrive. Is it the wreckage of an ancient interstellar voyage, or just a weirdly shaped rock that's fooled us all? Then there's the anti-gravity tree, defying physics with its upside-down rivers of ionized gas. Some of you might see nature's ingenuity at work, a freak of magnetism we've yet to understand. Others might wonder if it's a relic of alien engineering, a cosmic power plant harvesting energy from the void. And let's not forget the mirror fragments, reflecting light in ways no natural material should. Are they neutron star shrapnel or something far more deliberate, a surveillance system left behind to watch the galaxy? The comments section could light up with theories about the bioluminescent clouds. If those pulsating patterns are some form of communication, what might they be saying? A warning, a greeting, or just the cosmic equivalent of static noise? And what about the Time-Dilation Zone? If time moves slower there, could it be a natural stasis chamber, or a lab for experiments that need millennia to unfold? Here's the fun part: nobody knows. That's what makes Hoags Object so thrilling. Every anomaly is a blank check for speculation, a Rorschach test where you might see the handiwork of aliens, undiscovered physics, or just nature showing off. So hit pause and tell us which object keeps you up at night, the one that feels like it's hiding the biggest secret, because in a galaxy this strange, the best answers might not come from telescopes or equations, but from the wild, brilliant theories of curious minds like yours. And who knows, maybe one day we'll look back and realize a viewer's offhand guess was the key to cracking the whole cosmic puzzle. After all, the universe loves a good plot twist, and Hoags Object is writing them faster than we can keep up. From the phantom ring's ghostly flickers to the vanishing planet's prime-numbered disappearances, Hoags Object isn't just a galaxy, it's a gallery of cosmic anomalies that refuse to fit into any textbook. Each of these 30 objects twists the rules of physics in its own way. The quantum duplicates burning in perfect sync despite light years of separation. The gravity well's hexagon-tiled spikes warping spacetime like a glitch in reality. The bioluminescent clouds pulsing with rhythms that feel almost intentional. The more we study them, the clearer it becomes. This isn't just a collection of oddities. It's a masterclass in how little we truly understand. Consider how these mysteries stack together. The dark matter shouldn't exist without a visible anchor, yet its gravity tugs stars into obedient orbits. The anti-gravity tree defies every law of motion, its branches sipping ionized gas upward as if gravity forgot its job. Even the seemingly mundane, like the fractal asteroid's mathematically perfect cracks or the mirror fragments' uncanny reflections, whisper that nature might not be the only architect at work here. Layer by layer, Hoags Object peels back our assumptions, revealing gaps in our knowledge wider than the voids between galaxies. But here's the real magic. These aren't just puzzles to solve. They're invitations, the singing comet's harmonic radio bursts, the ghost ship's skeletal corridors, the cosmic eye's watchful void. Each one dares us to rethink what's possible. Maybe that's the greatest lesson of all. The universe doesn't owe us answers. It thrives on keeping us guessing, tossing us riddles wrapped in starlight and shadow, reminding us that curiosity isn't just a tool, it's the compass guiding us through the unknown. So keep looking up, keep questioning, because out there, beyond the edges of our maps, galaxies like Hoags Object are waiting not just to confound us, but to inspire the next great leap in understanding. And who knows, the next cosmic enigma might be the one that changes everything. Until then, stay curious, hit subscribe, and let's keep unraveling the universe's strangest secrets, one mystery at a time.